our player is now able to jump well, but if we enter play mode and fall down from one of the ramps, pressing space while in the air will make our player jump. This is because right now, when we leave the ground, our player keeps being in a grounded state. We'll solve this problem by adding a new state, falling. While I didn't intend to add falling until I introduced the gliding system, due to a few reasons I've decided to add it to the first part of the series. Because it wasn't intended to be added now, we haven't yet downloaded any falling animation. To do that, open up mixamu.com. In here, after logging in, make sure you select your game character model and then in the Animations tab, search for Falling Idle. We'll download it as is with the FBX for Unity selected and rename it to iBot at Fall. In Unity, open up the Airborne Animations folder and drag the downloaded animation into this folder. Then open up the asset and select the animation clip and press Alt-D. We now have our animation clip, so feel free to remove the asset we have dragged in. Select the animation clip and check the loop time option to loop the animation. With that done, let's now take a look at how falling works. We have our ground check collider that we already use in our jumping state. This simply allows us to go back to the idling state when we touch the ground again. To do that, we use the onTriggerEnter method. In the falling case, it will be quite the opposite. If, when we are in a grounded state, our trigger collider exits the ground, then we should start falling. When falling, the moment we enter in contact with the ground again, we'll go back to the idling state only until we don't have our landing states. We'll have to care about a few things regarding our falling state, but we'll understand them later whenever we finish the base of our falling. We'll start by creating the falling state script, so head over to the Airborne States folder. In here, create a new C# script named Player Falling State. Open it up and remove the default methods. Then swap the inheritance to inherit from player airborne state instead. Generate the necessary constructor. We'll need to cache this state, so open up the player movement state machine script. Duplicate the jumping property and rename it to falling instead. Don't forget to initialize it as well. Because we need the onTriggerExit method, we'll need to add it to our states, so open up the iState script. In here, duplicate the onTriggerEnter method and rename it to be onTriggerExit instead. When that's done, open up the player movement state script. Implement the necessary interface method and place it under our onTriggerEnter method in the iState methods region. Once you are done doing that, open up the state machine script. In here, duplicate the onTriggerEnter method and rename the enters to exit. Then open up the player script. Under the monoBehavior onTriggerEnter, call in the monoBehavior onTriggerExit method. I rename the parameter to collider. Inside, call in movement state machine.onTriggerExit and pass in collider. We now need to check if our collider exited the ground, so go back to the player movement state script. In the onTriggerExit method, we'll start by checking if we exited the ground by typing in if stateMachine.player.layerData.isGroundLayer and pass in collider ground.GameObject.layer. If it is a ground layer, we then call in a new method named onContactWithGroundExited, with collider as an argument. Make sure you return right after as well. I'll make this method protected virtual and add it under our onContactWithGround method in reusable methods region. You can name it onGroundExit or something else if you'd prefer. I've just named it like this to be something close to the onContactWithGround method. We'll now transition to the falling state with this method, but we'll do it in our player grounded state, as we can only exit the ground when we are grounded. So open it up. In here, in the reusable methods region, start by overriding the onContactWithGroundExited method. Inside, call in stateMachine.changeState and pass in stateMachine.fallingState. We'll extract this line into its own method, to which I'll name onFall. I'll make it a protected virtual method as well. This is just because we'll need to do something with it later on. Now, while this seems fine at first glance, we are currently starting to fall the moment we leave the ground. This means that we'll fall even if we have ground underneath not too far from the player feet. We don't really want that and don't mind it being considered a grounded state in this case, as the distance is small, so it won't really look weird. The floating capsule also helps it looking better as we'll somewhat teleport down. We'll check for ground underneath using a RayCast. So, start by typing in vector3 capsule collider center in world space equals to stateMachine.playerUtility.capsuleColliderData.collider.bounce.center. Then we'll create our ray by typing in ray downwards ray from capsule bottom, as we'll cast a ray from the bottom of our capsule and not the center, and assign it to be equal to new ray with capsule collider center in world space and vector3.down. For us to get our capsule collider bottom, we'll get its center and then add to it half of its height. Of course, we need to somehow get it. We'll cache this half height into a property. So, go to the script where the capsule collider data property is set by control clicking it. Then control click the capsule collider data class. If you can't do this, just go to the capsule collider data script. In here, right after our local center property, type in public vector3 collider vertical extents and give it a private set. We've named it extents because the collider has a bounce.extents variable which returns half of the collider size, and because we only need half of the height. So in our update collider data method, now type in collider vertical extents equals to new vector3 and pass in 0f collider.bounce.extents.y and 0f. We are now caching this every time our capsule collider is changed through the inspector. With that done, back to our player grounded state script. In our array, we now subtract to the collider center stateMachine.player.colliderUtility.capsuleColliderData.colliderVerticalExtents. We need to subtract because we want the capsule collider bottom and not the top. For our RayCast, we type in if not physics.raycast, which means we found no ground. We pass in downwards ray from capsule bottom for the first parameter and out underscore for the second one. This is known as discards. The RayCast method requires a RayCast it here, but we won't really need it. So instead we are telling C# to use a placeholder and say there is no value for this variable, which might even make it so storage isn't allocated. We now need a distance from our bottom to the ground, so open up the player grounded data script. In here, duplicate our base speed and rename it to ground to fall ray distance. We'll also update the range to be from 0f to 5f and default it to 1. Back to our player grounded state script, we now pass in movement data.ground to fall ray distance to the RayCast. For our layer mask, we pass in state machine.player.layerData.groundLayer, and then query trigger interaction.ignore, as we don't want to consider ground trigger colliders. Make sure you move the onFall method call inside of the if statement. This looks like it's over, but we'll actually need to do yet another check. Let's take a look at those two red obstacles we have created. We can see that there is a small gap in between them. Now, when we exit this obstacle, we'll enter the falling state as the ground is still a bit far. The problem here is that small gap. There are a few possible outcomes from this, but the main cause is entering the falling state because our RayCast saw no ground in the ray it casted, as it's a really thin ray. Problems like getting stuck in the obstacle or between the obstacles are possible because even though our capsule collider is big enough to pass this gap without falling, our RayCast didn't realize that there was ground a bit further. So we started falling and got stuck instead. What we'll do to fix this is cast not only our ray but also a box. This makes it so if there is ground really close to each other, or the player is going to fall a really small distance, we'll keep being on the grounded state. The box can have any size you want, but the best will be around the same size as the capsule collider or a bit smaller. We'll go with the size of our ground check trigger collider for this. Of course, we don't yet have a reference to our trigger collider, so we'll need to create a script to hold it. So, in Unity, head over to the player scripts data folder. In here, create a new folder named colliders. Inside, create a new C# script named player trigger collider data. Open it up and remove the default methods and inheritance. Make the class serializable as well. We'll create a property to hold the ground check trigger collider reference, so type in field, serialize field, public, box collider, ground check collider, and give it a private set. We'll need to add this to our capsule collider utility script, but it currently is a reusable class, while this new class is for the player only. Because of that, we'll create another class to hold it together with the collider utility. So, back into Unity, go to the player utilities folder and create a new folder named colliders. Inside, create a new C# script named player capsule collider utility. Open it up and remove the default methods. Swap the inheritance from onBehavior to capsule collider utility. Make the class serializable as well. Then add in a new property by typing in field, serialize field, public, player trigger collider data, trigger collider data. I'll give it a private set. When that's done, go to the player script and swap our capsule collider utility type with player capsule collider utility instead. This basically allows us to add more things into the utility that are specific to the player, without needing to change anything anywhere. You could, and likely should, go for composition instead, which is simply adding the capsule collider utility as a property instead of it being inheritance. But for simplicity, I'll go with inheritance, as again, that makes it so we don't really need to change anything else. If you prefer the composition way, add it as a property and make sure you update all usages to get there correctly. With that done, save everything and go to Unity. In the player game object, open up the Trigger Collider data area and assign to it the ground check game object. When that's done, open up the player grounded state script. In the same method above our if statement, we'll type in if is there ground underneath and generate the method. Inside of the if statement we will return, as that means we shouldn't fall. I'll add this method to the main method's region. In here we'll check for a box using the OverlapBox method. There are other methods to check for a box, but at least the checkbox method seems to count the transform we cast it from as well, even with a layer mask. So we'll use the OverlapBox instead. This method requires a center in world space from us, which is where the box will be positioned. We'll use our ground check box center for this. So start by typing in vector3 ground collider center in world space equals to state machine dot player dot collider utility dot trigger collider data dot ground check collider dot bounds dot center. Then we'll create a collider array named overlapped ground colliders and assign it to be equal to physics.overlapBox. For our center, we'll pass in ground collider center in world space. Next we have the size, but it actually requires half of it. So pass in state machine .player .collider utility .trigger collider data .ground check collider .bounds .extends. We are repeating this quite a bit, so above our vector, create another variable of type box collider named ground check collider and assign to it the ground check collider. Then swap it with where we use our ground check collider. For the third argument, we need the box rotation, so pass in ground check collider .transform.rotation. For our layer mask, we want the ground layer, so type in state machine.player.layerData.ground layer. Pass in query trigger interaction.ignore for the last argument. Now we can return overlapped ground colliders .length greater than 0, as that means we have found ground underneath our player. That shall get our falling working whenever we exit the ground, but we still have a few things to do. The first one is to not allow hair movement while falling, which we can do by setting the speed modifier to 0. So open up the player falling state script. In here, override the enter method. Inside, type in state machine.reusabledata.movement speed modifier equals to 0f. I'll add this method to a new region named iStateMethods. The second thing is to make sure we limit our falling velocity. This is because when falling, gravity will keep on increasing the velocity. When using ground colliders like mesh colliders or colliders that don't really have a lot of depth, because our velocity can be quite high, our collider will go through the ground at a speed that the collision won't be detected, even with our rigid body collisions set to continuous and all that. This means that we will simply keep on the falling state even though we have already hit the ground. To fix that problem, we simply limit our vertical velocity, which Genshin seems to do as well. We can do that by adding a vertical force to it in a way that it doesn't go over a certain limit. So override the physics update method and call in a new method named LimitVerticalVelocity. I'll add this method to an heuristic named mainMethods. We'll need to know what's our velocity limit, which means we need a data class for falling. So, back in Unity, in the airborne data folder, create a new C# script named playerFallData. Open it up and remove the default methods and inheritance. We'll make it serializable. In here, create a new field, serialize field, field range, from 1f to 15f, public float, fall speed limit, and give it a private set. I'll default it to 15f. Higher values than this might not work, so beware when setting it higher. Then open up the player airborne data script and duplicate the jump data property and swap jump with fall instead. When that's done, go back to the player falling state script. In our variables, create a new variable by typing in private player fall data. Then in the constructor, type in falldata equals to airborne data.falldata. Then back to our LimitVerticalVelocity method, we'll check if we have reached the speed limit by typing in if stateMachine.player.ResetBody.velocity.y greater than or equals to minus falldata.fallSpeedLimit. If that's the case, we return. Note that our speed limit is turned to negative here, so minus 14 will be greater than minus 15. Minus 16, for example, will be a higher speed fall than minus 15, but because it's a negative number, it means that it's slower than minus 15. Otherwise, if we have passed the limit, we'll set the current y velocity to be our max fall speed. To do that, type in vector3 limited velocity equals to new vector3 0f minus falldata.fallSpeedLimit minus statemachine.player.ResetBody.velocity.y and 0f. We are simply getting the difference between both here. If we are falling at minus 16 and the max is minus 15, then we'll add 1 to make sure we go to minus 15. Because we only enter this statement when the player velocity is stronger than the fall speed limit, doing the subtraction this way ensures we always receive a positive value, not needing to use absolutes. We are also getting our velocity twice now, so above everything, type in vector3 player vertical velocity equals to get player vertical velocity. Then swap the velocity.y lines with player vertical velocity.y instead. With that done, we simply need to add a force, so at the bottom type in statemachine.player.ResetBody.addForce and pass in a limited velocity and force mode.velocity change. We pass in velocity change as we don't want it to be over time nor to depend on the player mass. That solves one bug, so we only have two things left to do or solve. The first one is to transition from jumping to falling. This is because when we jump right now, we'll never start falling as there is nothing telling us to change states. Now we could have this happen in two possible ways. The first one is by setting an animation transition event on the frame that the jump animation gets to the top. However, while this may seem fine at first glance, there is a problem. Let's say we jump and there is an obstacle right above our player head. When we hit this obstacle, we'll start moving down due to physics. But because our jump animation still hasn't reached the top frame, we'll be falling while in the jumping state. The second way of doing it is the way we'll be fixing this problem. Simply transition to the falling state whenever our velocity becomes negative, as that means we are falling. So start by opening up the player jumping state script. In here, in the iState methods region, override the update method. Inside, we'll check if getPlayerVerticalVelocity.y greater than 0 and return if that's the case. Otherwise, we can transition to the falling state by typing in statemachine.changeState and pass in statemachine.fallingState. This is basically what is normally needed to transition from the jumping state to the falling state. But we need to keep in mind that we are using the floating capsule technique. This technique tries to keep the capsule collider afloat by adding a force to it. This is needed because the capsule collider would otherwise fall due to gravity. This means that our velocity will always become negative until the next add force method is called. Because of that, if we leave things as they are right now, it will enter the falling state right after we jump. Thankfully, it's quite simple to solve that. In our variables, create a new variable by typing in private bool can start falling. Then in our update method, we'll check if not can start falling and is moving up. We'll also pass in 0f to the isMovingUp method to make sure we check for the actual moment it starts going up. If that's the case, we'll set the can starting falling to true. Then in our state change if statement, we'll add in not can start falling or. The transition will now only happen if we can start falling and the player velocity is under 0 or negative. Of course, because we are caching in our states, we need to make sure we reset this variable to false when exiting. So in our exit method, simply type in can start falling equals to false. With that, we should have our transition to the falling state working correctly. However, I had a problem when falling off ramps that we will sometimes just randomly jump. I don't really remember the cause, but I remember that to fix it, I had to reset our vertical velocity when we enter the falling state. We don't reset our horizontal velocity because we still want to keep our horizontal momentum. So open up the player falling state script. Then in our enter method, type in ResetVerticalVelocity. Of course, we don't still have this method, so open up the player movement state script. Go to our reusable methods region to our ResetVelocity method. Under it, create a new method by typing in protected void ResetVerticalVelocity. Inside, we'll make it so that our vertical velocity becomes 0. So start by typing in vector3 player horizontal velocity equals to get player horizontal velocity. Then set a state machine .player.rigidBody.velocity to be equal to player horizontal velocity. The getPlayerHorizontalVelocity method returns a vector with y value as 0, which makes it so we are resetting the vertical velocity while keeping the rest being the same. If we now go to the player falling state script, the method shall no longer be throwing an error. This should be enough, so now there is only one thing left to do, which is to override the ResetSprintState method and leave it empty. I'll add this method to an region named reusable methods. This override is required because now our jumping state only happens until we are at the top, so we need to make sure we keep sprinting after we fall as well. Of course, because we can jump and go to the idling state in certain situations where we jump to an higher leveled ground, we can keep the jumping state override as well. However, we need to remember that we can also go from a grounded state to the falling state. This means that in our sprinting state, we also need to set the shouldResetSprintState variable to false when we start falling, much like what we did for when we jumped. Thankfully, we have previously created a virtual method named onFall that will make it easy for us to do that. So open up the player sprinting state script. In here, in the reusable methods region, override the onFall method. Before we call the base method, we simply type in shouldResetSprintState equals to false. This means that if our shouldSprint becomes true, it will now not be reset when we fall. Note that the shouldSprint should only become true if the sprint key was held long enough, which is how it works in Genshin and is how it's working for us as well. That should be all that's needed for falling, so save it up and go to Unity. Entering play mode, we shall now be able to fall correctly.